Alright, this video is on type 2 ionic compounds and the nomenclature for these compounds. So first thing we want to get into is what's the difference between a type 1 and a type 2? Alright, well, a type 1, the type right here is mainly referring to the cation. Alright, it's type 1 cation or type 2 cation. The anion, right, remains unchanged, right? So when I look at, say, this table right here, okay, the anions that I have listed, those anions are not going to change their charge. They're always going to be negative. Hydride's always going to be -1. Fluoride's always going to be -1. Chloride -1. Bromide -1. So on and so forth. Okay. There's one missing here, and that is actually two, but they both happen to be the same charge, is the nitride ion and the phosphide ion, right? Nitride and phosphide. Those are some important ones that you will need to know. But it's important to know that they don't change. Now, these guys all over here, these all happen to be type 1 cations. These are type 1. And the reason why they're called type 1 is because if you look at the charges, there's only one type of charge. There's only one charge, right? Hydrogen is only a +1 charge. Lithium can only be a +1 charge. Sodium can only be a +1 charge. Beryllium can only be a +2 charge. Aluminum can only be in +3 charge. Now, there's one little outlier right here, because all the rest of these guys, they're all found in the main group elements. Silver is not. Silver is in the transition metal block. It's in the D block. But as it turns out, silver is one of those unique exceptions where it'll only form a +1 charge. So you can treat it like a type 1. So silver, okay, will form only a +1 charge. It is only a type 1. Okay, all these ions right here are all type 1. Now, type 2 has to do with a varying number of charges. Okay, these are your transition metals, right? Here I have two different irons, I have two different coppers, I have two different cobalts, two different tins, two different leads, and two different mercuries. Okay, these are the ones that we're going to be using often. Okay, that doesn't mean that they're the only ones we're going to use. In fact, I'll show you a way in this video to, doesn't matter what the ion is or what the cation is, you'll be able to determine what the formula is and what the cation is, because the anions, like I said earlier, don't change. And you can use those anion charges to determine what your cation charge is. Okay? To everybody's, I'm sure, bliss, these older names, you are not going to be responsible for. Okay? Don't even worry about them. Now, the systematic names, iron 2, iron 3, those are ones that we are going to be familiar with, but it's pretty simple, right? Iron 3, 3 plus. Cobalt 2, 2 plus. Tin 4, okay, 4 plus. Okay, pretty straightforward. The one exception to the rule as far as it being easy is this mercury 1 ion. And you think, well, there's two mercuries there. Why is it called a mercury 1 ion? This is what we call a polyatomic ion. And I'm going to leave this polyatomic ion alone for now, just because our next video is going to be on polyatomic ions, where I will revisit the mercury 1 ion. But for right now, we're going to focus on these guys, iron 2, iron 3, which you guys are already familiar with. You already did a lab with them. Copper 1, copper 2, cobalt, tin, lead, okay? That's what we're going to focus on as of right now, okay? So let's go ahead and do some examples and some different tasks that I'm expecting you to know how to do, all right? One of them is, if I give you the name 10,2 chloride, you need to tell me what the formula is based on that. Right? Well, hopefully this right here is the red flag. Chloride, that's Cl minus. And then 10,2, which doesn't take much of imagination to figure out what this is. This is 10, which is Sn, and it's 2 plus. So if I wanted to know what the formula was for 10,2 chloride, it would be SnCl. Cl2. All right? So that's one thing. I'm going to give you a name, and I expect you to give me the formula. Okay? Oops, not quite. Let's go ahead and clear this. And we'll go with another one. How about iron 3 sulfide? Okay? Again, same principle. You should be able to do this because all I'm doing is I'm going to go sulfide because I know the anion doesn't change. Sulfide is -2 based on the periodic table. And then iron 3 is Fe3 plus. So now that I have my ions, it just goes back to applying the same rules of flipping the switch or counting out your protons and electrons, however you want to do it, right? In this case, if I brought these two together, it would be Fe, ooh, that's not an E, Fe2S3. And that would be iron 3 sulfide. Like I said, that is going to be one task I'm expecting you to do is if I give you a name, you need to be able to give me the formula, okay? And also tell me the ions, but that's pretty easy. Okay? The other one is, what if I give you the formula, right? What if I give you a formula and I want you to go back up to the name? Well, in that case, you know what it means. It means I have to go here first and then go to the name, okay? So let's go ahead and take a look at one of those guys. How about okay? How about PbCl4? Okay, which you could say, oh, that's lead chloride, but remember, because lead is a type 2, you need to identify which ion it is, because lead can be 2 or it could be 4. Okay, so taking a look at this, I need to get the ions from this. Well, as it turns out, I happen to know that chloride is always going to be -1, right? And looking at the formula, I had 4 chlorides in order to make this neutral compound, which means my lead, in order for this to be equaling, 4, -1, right? This has to be something to equal 0, right? Because I need to have my compound be neutral. So looking at this, this is -4, plus x plus -4 is 0. That means lead is 4. So if I was to write out the name, or in this case it'd be 4 plus. If I was to write the name out of this compound, it would be lead, Roman numeral 4, chloride. Okay? Like I said, it's pretty basic. If you understand the basic rules of nomenclature, it's going to work out for you. Okay? Let's do another one. Let's try this one. How about okay? That's copper oxide, right? Copper and oxygen, that's copper oxide. But again, copper's transition metal, so I have to break it down. So my oxygen, change colors here real quick. Oxygen I know is 2 negative, right? Well, that means I have 1 oxygen, so that's -2, right? Equals 0 plus x. That's my copper. This x, or this variable, will tell me what the charge is going to be of this copper ion. In this case, x plus -2 equals 0. That means copper is really copper 2. Okay? And if I was to write that out, it would be copper 2 oxide. All right? So let's go ahead and kind of look at a flow chart to kind of decide whether or not it's type 1 or type 2. Okay? So if I have a binary compound, which means it's composed of, just 2 different elements, okay? If it's a binary compound, then I go to, is there a metal present? If there is no metal present, then it's type 3, which we'll talk about next, right? Which is our polyatomics. Or excuse me, not our polyatomics, our covalent compounds, which we'll talk about later. Okay, but if a metal is present, which every single case so far it has been, now we need to know, does the metal itself form more than one cation? And how I know that is, if it's a main group element, right, or silver, right, then it can only form one cation, and that means I'm going to use my type 1 rules, which is the element, the cation's name, right, silver, and then chloride, or silver nitride, or whatever. Okay, but if it has more than one cation, then you have to look at the Roman numeral to determine what the charge of that cation is going to be. All right. So again, if we're looking at your expectations, right? I'm expecting you to go from name to ions to formula. Okay. And I'm also expecting you to go from formula to ions to name. All right? You should be able to do both. All right? If you guys have any questions, please send me an email or ask me in class.